Hello everyone, today I'll show you one of the most popular syntax recognition and detection algorithm MMOCR and how we can implement it in pycharm. Step by step I will show you all the things. So before going to implementation, I will just give you some basic idea about the MMOCR model and the working procedure, how it's work. So basically mmocr is an open source toolbox based on the pytorch and mmdetection for the text detection, text recognition and the key information extraction from the image. So what is text detection? Basically text detection model or algorithm will find where is the text inside the image. Basically detection algorithm or detection model will return some important information like the bounding boxes where the text inside the image, and text recognition algorithm will find, or the text recognition model will find what is the text like wild, feminist, this text will recognize. So one of the most important things makes it different from the other OCR model. MMOCR model is the modular design, because in MMOCR model we can use different types of detection and recognition model for the text detection and recognition, and this modular design basically makes the MMOCR model different from the other OCR model. Here you can see the Python command for this different type of detection and recognition model. Here you can see the list of text detection model like DBNet, PP, FCNet, MaxR-CNN, lots of detection models. And also you can see here below the text recognition model like ABINet, CRNN. Here you can see the CRNN model is used for the text recognition, and DBNet model is used for the text detection. So inside the MMOCR inference you can use different type of detection and recognition model listed here. So basically this modular design makes the MMOCR different from the other OCR model. So now I will show you the text detection model DBNet basic idea, how it decided where is the bounding boxes of the text inside the image and how it's work. Basically DBNet, which is used for the text detection, basically text detection algorithm will return the bounding boxes of the text inside the image. So this differentiable binarization network is a segmentation network which perform binarization process. Segmentation network can set the threshold for the binarization, and it is also simplifies the post processing and enhance the performance of the text detection. So basically here is the image, and this DBNet network will generate the approximate binary map, and then bounding boxes will be generated from here. So with the DBNet we can add ASF, adaptive scale fusion, to improve the performance of the DBNet. It's basically improve the scale robustness by fusing features of the different scales adaptively. By incorporating both the DBNet and ASF or adaptive scale fusion with the segmentation network, basically this is the segmentation network, and we add here a adaptive fusion scale module. Then it can consistently detect syntax and achieve the state of art result in terms of detection accuracy and speed on 5 standard benchmark. Basically in the DBNet network we just add another additional adaptive scale fusion module to generate more accurate approximate binary map, and from where the DBNet model will generate the bounding boxes of the text inside the image. So basically this is the basic idea how DBNet model detect the text, and now we can go for the step-by-step implementation. And basically I will show you here. During the implementation of MMOCR model, I basically use today DBNet model for the text detection and ABINet for the text recognition. Here we will use DBNet, and here we use ABINet for the text recognition algorithm or model. And now I will show you how you can implement it in pycharm. During the implementation step, first we need to open the pycharm terminal, and we need to install some important related package to implement the MMOCR model. So first I will show you the steps to implement the MMOCR model. Clone the MMOCR from the GitHub, then need to install torch and torchvision. Then in the third step we need to install basically mmengine, mmcv, mmdetection, mmcls and mmocr. And then in fourth step we need to create two directory for the detection and the recognition, because you use different two model. One is for the text detection. Here we will use DBNet, and for the text recognition we use ABINet. That's why inside the weight directory we need to create two directory for the model weight inside these two directories. And finally we need to download these two model weight from the link, GitHub link. In the pycharm, first we need to clone the mmocr from the git. So just need to copy this line and paste it in the pycharm terminal. It's take little bit time to download. So it's already done, and mmocr directory created inside to install torch and torchvision. We just need to simply type 1.12.1 version. So you can see here the requirement already satisfied because I have already installed it. And then we need to install torchvision 0.13.1. so here you can see the requirement already satisfied. Then we need to install this one by one. Basically I will give all the command in my video description box, so from here you can use it. Requirement already satisfied. I have already installed all of this package, so just you need to copy one by one and paste it in the pycharm terminal. So it's very simple. Requirement already satisfied. Just you need to one by one copy and paste it here. All of the packages I have already installed. That's why here you can see the requirement already satisfied. You just need to install one by one all of this, and finally we need to create two directory. So inside mmocr we need to create two. First we need to create weights directory, weights, and inside the weights we need to create another two directory. One is DBNet and another is ABINet. And now we need to install the model weight for the ABINet and DBNet. So just we need to copy another two line. From here you can just copy and paste it here, or another way you can download. You just need to copy this link and then open the Google Chrome and just paste it here. Then model weight will be download here. Then just need to move this model weight file from download directory to the respective project directory. So I have already downloaded this, that's why I need to cancel. So another is ABINet. You just need to copy the link and paste it in the Chrome, then automatically download the ABINet, which is used for the text recognition. So from the download directory you just need to move this to the respective project directory in the pycharm. So I have already downloaded all of these two model weights, that's why I cancel it, and I'll show you how you can copy and paste it in the respective directory in the project. So you just need to copy this ABINet model weight, copy, and paste it in the ABINet directory. Just paste it here. And another one is DBNet. So you just need to copy this and paste it inside the DBNet directory. So now you can see here inside the ABINet directory you can see the model weight, and DBNet directory you can see the respective DBNet model weight. So now implementation environment for the mmocr is ready. So just now we need to create a Python file. Then we need to import some important Python packages. Then we'll import supervision. Supervision is used for display the image from mmocr.utils.poly2boxes and from mmocr.apis.inference import mmocr-inference. Then first we need to set the device. Device is torch.device CUDA 0 if torch.CUDA is available, else CPU. Now we can print the device and run it. Here you can see CPU because I don't have any GPU here. Then you need to assign 4 parameters for the model configuration path and the model weight path. Two model is used, one is for the text detection and another is for the text recognition. Text detection basically return the bounding boxes and text recognition return the actual text inside the image. So we need to assign 4 variable here. One is detection config path. Then another one is detection weight path, basically model weight that we have downloaded. And another two is recognition config path and the recognition model weight path. So just need to change this recognition config path and recognition weight path. Now I will show you how we can get this 4 variable path. First I will show you the config path for the detection and the recognition. For getting this path we need to go mmocr, and here you can see the config directory, and inside the config directory you can see the text detection and the text recognition. So mmocr basically used two model, one is for text detection and another is for the text recognition. So inside the text detection directory you can see lots of model here, DBNet, DBNet++, marksrcnn, lots of available model here. Basically I have downloaded earlier the DBNet++ model weight, that's why I need to go inside the DBNet++ directory, and here I have basically downloaded this model weight, that's why I just copy this path, config file path, and paste it here. And for the text recognition I just need to go text recognition directory, and here you can see the lots of available model, ABINet, CRNN, lots of model here. I have downloaded the ABINet model weight for the text recognition, that's why I have to go inside the DBNet directory, and here this file need to copy, this file path need to copy and paste inside the recognition config path. Then we have to assign another two path, detection weight path and the recognition weight path. I have already downloaded the model weight and keep it inside the weight directory, and here you can see the DBNet and the DBNet. So DBNet is used for the text detection, and the model weight already downloaded inside here. So I just need to copy the model weight path and paste inside the detection. And another one, the DBNet model weight is here, so we just need to copy the model weight path which is used for the text recognition and paste it inside the text recognition path. Now we need to call mmocr inference. So here we can assign a variable mmocr inference is mmocr inference. Here we need 5 parameters. First one is the detection. So detection is the detection config path, and detection weight is the detection weight path, and another two is recognition. Recognition is recognition config path, and recognition weight is recognition, and last one is the device. Device is device. Now you can check the mmocr is perfectly working or not, and process finished with the exit code 0. So it's working fine and there is no issue. And now we need to read the image and send this image to the mmocr inference for getting the result. Basically using opencv I will read the image. First we read the image 3 and then convert this image to RGB and resize both of the image. Now we just need to send this image RGB to the mmocr inference, RGB image to the mmocr inference for getting the result. Inference result. So here you can write just result is mmocr inference, then just send image RGB. First we need to check the result keys, result dot keys. Then we get here you can see the prediction and the visualizations, two keys inside the result. So we just need to print the predictions, and we can write here just result. And first of all we need to see the image 3. Here you can see two text, so we need to check the predictions. Actually mmocr inference will return the recognized text inside the image, detected polygons, recognition score, and also the detection score. So here you can see the recognized text and perfectly it recognized. Here you can check it's perfectly recognized the text from the image, and also it will return some parameter like recognition score. It's very fantastic, 92%, 99%, detected polygons, and the detection score. Basically we need the detected polygons and the recognition text for processing further, because we need to convert this detected polygon into the bounding boxes, and then we put rectangle over the text. First we need to convert these detected polygons into the bounding boxes, then we need to draw rectangle over the text using these bounding boxes. So it's very simple. Now we need to Now you can keep the prediction result like recognize text and the detected polygons in separate variable. So we can write here text is result, then we can just copy this and paste it here, and detected polygons is result, and here we can just copy these detected polygons and paste it here. We can check it again, print detected polygons and print recognize text. Maybe there is some issues. uh, uh, Actually all of these parameters was in the prediction 0, that's why we are getting this error. Hope it will solve the issue. Successfully recognize the detected text and we have got the detected polygons. Now we just need to convert these detected polygons into the bounding boxes. So just few lines of code here to convert this polygon into the bounding boxes. Detected boxes is torch dot tensor, then here np dot array, here poly2 boxes that I have imported here, then here you can write poly for poly in detected polygons, this detected polygons, and we can set another just device is device. Now you can check the detected boxes. We have got the detected boxes here, but in form of the tensor. So we need to convert this into np arrays. And boxes is detected boxes. If we print now, yes, we have got two separate bounding boxes for these two detected text inside the image. Now we need to draw bounding boxes over the detected text inside the image. So we can simply use cv2.rectangle command to draw the bounding boxes. So we can write here for bounding box in detected boxes, then x1 y1 x2 y2 is bounding boxes. Then we can simply use this command over the image bezier. We can draw the rectangle using this coordinate. We need to convert it to integer, then we can display the image. We use supervision for displaying the image. So sv dot plot image grid, here we can use images is original image and image bezier. So we can keep the copy of original image here, image is image bezier, original image and image bezier, Then we need to assign the grid size. Then we need to assign the grid size. Grid size should be 1/2. Then we need to set a title. One is original image and another one is mmocr image. Now you can check it. Yeah, successfully the mmocr model recognize the text and draw the rectangle over the detected bounding boxes. Basically, in this way we can detect and recognize the text inside the image. We can display the recognized text over the bounding boxes because we have recognized the text successfully here, and we can display this over the bounding boxes. For this we just need to add one more line, cv2.put text. So it's very simple, image bezier cv2.put text, and here is the recognized text. We just need to initialize the counter over the loop. We can set the counter variable is 0, and here we can increase the counter variable. In this way, basically from this recognized text we can display the label over the bounding boxes. Basically this is all about the mmocr implementation in the pycharm. mmocr gives us the flexibility to choose different types of text recognition and text detection model. Basically, the modular architecture of the mmocr model gives us the flexibility to choose from the listed detection and the recognition algorithm for the text detection and the text recognition. So here you can see that inside the mmocr directory you can see a config directory, and here text detection and the text recognition. Inside this two directory you can see lots of model is available here: DBNet, DBNet++, marks-rcnn for the text detection, and for the text recognition ABINet, CRNN, NRTR. Lots of model available model is here, and basically I have used here DBNet for the text detection and ABINet for the text recognition. If you wish to use different model, like if you want to use marks-rcnn for the text detection, you can use it, or for the text recognition if you was to use CRNN, then you can easily use it. But how you can use this model? Basically, if you wish to use marks-rcnn for the text detection, then you have to select detection config path here, and you have to download it, the marks-rcnn model weight, from the GitHub. But how you can download it? Just you need to search here mmocr GitHub. Then you have to click the link and just scroll down, and here you can see model Joe and text detection, lots of available model here, and for the text recognition you can see here lots of available model here with ABINet, and here is the DBNet++. Basically DBNet++ is the latest one, and here adaptive scale fusion applied on the DB network, and it gives us the more accurate binary map for the text detection inside the image. That's why I have used it. But if you want to use marks-rcnn for the text detection, then you can just click in the link, and if you wish to use CRNN for the text recognition, just you need to right click on this, open in new tab, and here for the marks-rcnn for the text detection, you can download any one of the listed model weight here, and you have to assign respective detection config path according to the model name, downloaded model weight name. Similarly, if you wish to use CRNN for the text recognition, you just need to download the model weight from here, and you have to carefully assign the model config path from here. You just need to right click here, copy the path and paste inside the model config path. So basically this modular architecture gives us the flexibility to choose various text detection and recognition algorithm inside the mmocr inference. Basically this is all about the mmocr model which is used for the optical character recognition from the image, and it's really fantastic because of its modular architecture. If you wish to watch my next video from my channel, please subscribe me. Thank you very much.